All right, so I'm going to look at horizontally launched projectiles, and Pfaff put up an assignment and some notes, but I'm going to work through that assignment for you. But first I want to show you, there's this simulation on PhET, and you can look it up, just Google PhET projectile motion, and you can actually go ahead and mess with all of this horizontally launched information. So if you keep this cannon at 0 degrees and you can launch, let's say we just are going to launch something at 20 meters per second out of the cannon, and we'll launch a pumpkin since it's fall. We're going to stand 9 meters tall. So you can see that as I fire the cannon, the pumpkin is going to launch out and create this beautiful like blue arc right here. And that is going to be half of your parabola motion. And so that is a horizontally launched problem. So when you're looking at these problems, I put in the notes that there are several things that you want to remember, and I'll talk through those things as I work through the problems. So down here, let me get my screen set up. I have the formulas and I have his assignment that he posted. And so looking at these formulas, he kind of lists them differently in his notes, which is fine. They're both the same thing, just a bit different. I'll go ahead and tell you what mine means. So in the horizontal motion, gravity does not affect horizontal. So we don't have anything with acceleration in it. So we just have this one formula, dx equals v, and I could put a little x there if I wanted to. Dx equals vx times t. And so, try to get rid of that line for you. So that's the only formula we have for horizontal, because gravity does not affect the horizontal motion. Vertically, we can solve for all sorts of things, and you can see those formulas here. Gravity is the acceleration, so I've just put a g where a typically is. And then to find time, you can use this formula here, t equals square root 2 times the height divided by the acceleration, which is gravity. So there's the formulas, and I've just substituted a few things like distance in the y direction for the, x or y, and then VIY means the initial vertical velocity, dy, distance vertically, VFY is the final velocity in the vertical direction, and VIY, the initial velocity in the vertical direction. So that's just a few hints on the formulas that I use. If you have any questions about that, just let me know. Okay, so I'm going to work through his 6 problems here. The first, I like to draw pictures. That helps because you can see it and make sure that you don't use any horizontal information in a vertical formula or vertical information in a horizontal formula. And so right here it says a ball is thrown from a tower 55 meters above the ground. So I'm going to just quickly draw a tower, and it's 55 meters up, and the ball is thrown with a horizontal velocity of 15 meters per second. The question wants to know how long will the ball be in the air. So we're solving for time in this situation. Now, if I want to list my givens, I'm going to list givens in an XY chart like this so that I can keep my horizontal and vertical information separate. So x is horizontal, so I only have the velocity in the x direction is 15 meters per second, and that was given in the problem right there. And then I have in the y direction that we have a distance in the y direction of 55 meters. I also have gravity always, negative 9.8 meters per second squared. And then I need to find time. So if something is shot out horizontally like that, I'm going to say always that the VIY is equal to 0. So I can use, this formula right here to solve for time. And that is where this formula down here comes from. It's just all rearranged. And so to solve for time, I'm going to say this keeps doing that. Draw. All right. So plug in your numbers. T equals square root 2 times 55 all over 9.8. Now I'm going to remove the negative. I'm going to take that out. of the 9.8 because when you put it in your calculator, you don't want to take the square root of a negative, you'll get an error. Now, you could, because everything's going down, make the 55 negative and the 9.8 negative, and that will make it positive. But I'm just going to go ahead and just remove the negative for the purposes of ease. All right, so 2 times 55 is 110 divided by 9.8 is 11.2244, blah, blah, blah. I'm going to take the square root of that number to get t equals 3.35 seconds. All right, so then it says, so remember that time is the only thing that you can use in both horizontal and vertical. Time is equal in both of those. So I can say time is 3.35 all across the board for both of those, for horizontal and vertical. So B says, how far from the base of the tower will the ball land? So that's going to be the distance in the x direction. So I only have one formula for the x direction. dx equals vx times t. Dx is what I'm solving for. The horizontal velocity, so it was shot out at 15 meters per second. And the time it took, we already solved for 3.35. So 15 times 3.35 is 50.25 meters. That's how you would solve number 1. All right, I'm going to try to go a little bit faster now that I've done the first one. Number 2. Keep deleting things. Okay. All right, so here we go. X, Y. It says a person can throw a water balloon at a velocity of 20 if they're on a tower 15 meters tall, so dy equals 15 meters, and throw the ball horizontally. So the velocity in the x is 20 meters per second. All right, so t equals square root 2h over g, or a. T equals square root 2, the height is 15, not 20, 15, over that negative. I'm going to take that negative out, 9.8. So 2 times 15 is 30, divided by 9.8 is 3.06. I need to take the square root of that to get 1.7. I'll round up to 5. So t equals 1.75 seconds. And then I can take that information down here to this question and say, well, how far from the base? Remember, we're solving for dx. The only formula we have for dx is dx equals vx times t. Dx we don't know. Vx right here is 20. T was 1.75. So 20 times 1.75 is 35. 35, and it's a distance, so it's meters. Okay, and then number 3. All right, I'm trying to give you some room here. All right, number 3. My givens are my x and my y. A ball is pushed horizontally off of a counter that is 1.5 meters above the floor. So that's going to be the distance in the y direction. And it's pushed out at 3 meters per second. So that's going to be the velocity in the x direction. Find the time. T equals square root 2h over a. T equals square root 2. Height is 1.5 over 9.8. 2 times 1.5 is 3, divided by 9.8 is 0.306122. To take the square root of that number, and you get t is equal to 0.55 seconds. Okay, using that time that we just found, we're going to go down and find the horizontal distance that the ball travels. So horizontal distance is dx. The only formula we have there is vx times t. So dx equals, the vx was 3, and the time was 0.55 seconds. So 3 times 0.55 is 1.65 meters. There you go. Number 4, it says an arrow is shot horizontally. Okay, so we're going to separate these two. Whoa. All right, arrow shot horizontally, so x is horizontal. So the velocity is 75, and the distance in the y direction is 60 meters. How long? So t equals square root 2h over g or a. T equals square root 2, the height is 60, all divided by 9.8. 2 times 60 is 120 divided by 9.8 is 12.24. Take the square root of that number and you get a time of 3.5 seconds. Taking that information down here, we want to know how far from the base, so that's dx equals vx times t. We don't know dx. Vx from up here was 75, t is 3.5. So 75 times 3.5 is dx equals 262.5 meters. All right, and number 5. There we go. Number 5, a ball is kicked horizontally off of a roof. My letters are all off. Okay, ball is kicked horizontally off of a roof. So the roof, the distance in the y direction is 10 meters, and it's kicked off with a velocity in the x direction of 8. Find the time the ball is in the air. Okay, so that is going to be, whoa, that's a t. All right, t equals square root 2h over a or g. T equals square root 2, the height is 10 divided by 9.8. 2 times 10 is 20. 20 divided by 9.8 is 2.04. Take the square root of that and you're going to get 1.42. So time equals 1.4. I'll round up to 43 seconds. We take that information down here. Find the horizontal distance. So dx equals vx times t. Dx equals vx was 8 and time 1.43. So dx equals about 11.43 meters. All right, last one. A ball is thrown horizontally. I'll just give myself some room here. All right. A ball is thrown horizontally from a tower. If you want me to draw a picture, again, that might help you. So the tower is 12 meters above the ground and an initial velocity of 26 meters per second. How long? So the ball's going to go like that. So we want to know how long will the ball be in the air. So that's t equals square root 2h over a. T equals 2. The height is 12 over 9.8. Don't forget the square root. Okay, so 2 times 12 is 24 divided by 9.8 is 2.448, Take the square root of that number and you get 1.56 seconds. And then it says how long, let's see, how far from the base. Up here it says how far from the base of the tower will the ball land. So that's going to be dx equals vx times t. Dx equals, the vx is the 26. The t was 1.56. 26 times 1.56 is 40.566 meters. All right, if you have any questions, please don't hesitate to let us know.